Alright, let's cover factoring. This is the first video I'm ever going to do that was requested via the power of the internet instead of meeting someone in person or talking about it with somebody in one of my classes who needed help. So thank you for actually sending in that request, and if anyone else has any requests, please continue to send them in. This is really the direction I want to do, is what do you need and what will actually help other people in the future. So send them, and don't hesitate to comment on any of the videos. I'll be monitoring them. But today we're going to talk about factoring. But before we actually start factoring any numbers, we need to learn the difference between a prime and a composite number. And a prime number can only be divided by two unique numbers, and these numbers are one in itself. Now you see I underlined unique or highlighted under it in a different color because we have to consider the definition of what a unique means. So if we take number 1, 2, and 6. Let's just look at these and factor them out really quick. I'm writing with the eraser, I knew it felt weird. So let's just look here. We always start with our lowest prime number, and we can say 1, but we're going to show that 1's actually not prime here in a second. And that's actually a very important thing to remember, because on the GK test, I know when I took it, and I know other people have told me, one of the questions they ask are, how many prime numbers are between 1 and 20? And 1 is not prime. I'm going to show you why. So if we take 6, I'm going to start with, yes, it's divisible by 2, and that is 2 times 3 is 6. Here we have 2 and 3. Those are both unique. They're not the same number. They're not repeated. Therefore, those are unique factors of 6. Now we're going to look at 2. 2 we know is prime, and when we break down 2, we can only do 2 times 1. 2 is unique compared to 1, and those are all of our factors. Therefore, 2 does fit and satisfy the definition of prime that we have on the screen. But if we go to 1, 1 could be divided by 1 in itself, and is therefore not prime because both factors are repeated and it is not prime. So a composite number is a whole number that can be divided evenly by numbers other than 1 or itself. Showing you with 6, we're going to go a little bit larger. Let's do 21. That one will arrive at really fast. So we're going to do in our heads. Can 21 be divided by 2? No, it cannot. Can it be divided by 3? Yes. 3 times what is 21? 7. 7's prime. So we have the prime numbers 3 and 7. Those are the prime factors of 21. We'll do one more, and then we'll move on to actually factoring and talking about some of the tricks when you're factoring. Let's do 32. So mentally, can it be divided by 2? Yes. And 2 times 16 is 32. This can be broken down to 2 and 8, which can then be broken down to 2 and 4, which then can be broken down to 2 and 2. So the prime factors of 32 are 2, 2. We're going to mark them off as we use them. 2, 2, and 2. So what we're showing here is that 2 times 2 times 2 times 2 should be 32, or 2 to the 5th power is 32. 2, 4, 8, 16, 32. That is correct, and that's how you start factoring. Alright, so we're going to move on to where we actually have to look at the radical and to what root that radical is actually being done to. And then we're going to discuss how to factor prime numbers or composite numbers out of a radical and move forward from there. That's where most people start getting confused, but I really wanted to touch this basic topic first.